welcome to the session. Thank you very much for joining us and sticking out VMworld to the bitter end here. I think there's just only a couple more hours left, but really appreciate your coming in here in the morning like this. First thing I want to do is, since we've got product manager on the stage, we can't help it but talk about futures sometimes. So it's in our DNA. So want to make sure that we make it clear with the disclaimer here that we may be talking about features that are currently under development, and but we are not going to be discussing any timelines, and you should not be making any purchase decisions based on what we discuss. So in the way of introductions, I'm going to start here.
Sure. Hi, everybody. My name is Jarrett Rain. So I run strategy and operations for Rackspace Managed Security. So we're the managed security service provider that's part of Rackspace, and we help customers secure their workloads on various clouds.
And my name is Rod Batchelor. I am one of the product managers in the network security business unit. We do NSX.
Does it work? Excellent. So my name is Rob Truesdell. I'm responsible for product management at Phantom. At Phantom, we build a security, automation, and orchestration platform. We partner with NSX on an integration to enable automation against NSX, and Rackspace utilizes both technologies in their environment today.
Thanks. And if you're going to see us keeping a looking back and forth when we talk at the same time, there's some interesting technical challenges. We're on the same microphone channel right now. So if you want to ask us both a question, it can't be done. So I'm going to talk a little bit here, talk a little bit about the security challenges in the data center and so on. But first of all, what I want to do is get a better idea of who we're talking to. So it's time to exercise your arms. I'm going to ask for some show of hands here. First of all, so how many of you would describe yourselves as on the IT operations side? Okay. How many of you focus on security? Okay, so we've got a pretty good cross-section here. That's great. I'm actually really happy to see that. So when we are talking about NSX and security automation, and honestly, when we're talking about virtualization in general, there are a number of things that have not changed. The first one, of course, is that we're always about the app, right? It's about the application. This isn't about the infrastructure. It's not about the servers or the hardware. It's really about the application. It's why we're all here. And of course, we're going to be talking about the security of the applications and so on. But it's not only that. It's also speed. We're always under pressure to deliver faster and faster. You know, we talk about the instant-on marketing campaigns, right? Somebody comes up with something, next week it needs to be out there, it needs to be up running for a month, and then taken down again. And then availability, of course. But a number of other things do change. When we talk about changes in the threat landscape, the interesting thing here is the one thing that doesn't change is that there's always change. The threats that were advanced threats that were propagated by government actors or so on, or nation states, these things over the next few years become embedded for sophisticated hackers, and beyond that, pretty soon they're going to be in the hands of the script kiddies. So protecting yourselves against yesterday's threats doesn't apply. The application architectures, I think, how many of you are looking at containerization or serverless? Yep, so a number of you there. This is something that's coming up very quickly. There were some great announcements on the pivotal container services and so on. But these also become a challenge for us. And lastly, in infrastructure, and we have our announcements about the VMware Cloud on AWS, enabling the hybrid cloud, or moving to a fully hosted, or keeping it in-house. There's a huge number of ways to deploy applications as well. So when we come to a data center, though, the data center has its own unique challenges for security. And I speak to this as a security professional. I joined VMware about a year and a half ago. And my background was always in security, and to me the data center was a little mysterious. But one of the real problems that we have inside the data center is visibility. The fact that we can't see that east-west traffic because it's sitting inside of a rack or it's sitting inside of a host. The control points. Where can we put those control points? Where can we apply that security? Where can we do the segmentation and isolation? Integrating multiple vendors. Every vendor, you've had security solutions in your data center for a long time. That's where your crown jewels are. And they all have their own, management applications. They all have their own policy infrastructure and so on. And they all have their own ways of logging, et cetera. And lastly, the lifecycle management associated with all of those applications. Being able to deploy and manage, dealing with any kind of the mobility of the applications and so on, and being agile enough to keep up with the business. So I'm going to pass it on to Jarrett to give more of a customer perspective on all of these problems.
Sure. So as I mentioned, I help run our managed security practice at Rackspace. And so the goal of the managed security practice is to be able to deliver modern security operations for customers on a variety of infrastructures, right? So that includes dedicated servers, that includes VMware, AWS, Azure, Hyper-V, these different platforms that we support, right? And so as we look at actually delivering that operation, the important component for us is the operation is the same across those infrastructures, right? And so a modern security operation kind of consists of a couple of key factors. Right? To be able to defend against modern threats, it has to be a 24/7 operation, right? And so, for example, at Rackspace, our busiest time are 2 to 3 o'clock in the morning because that's when the PLA gets to work. And so, in a lot of cases, you have to be able to cover that entire shifting, and it has to be data enabled, right? The vast majority of security operations have typically sat on top of a set of tools that have been deployed in the environment. You wait for them to tell you to do something, and that's just not enough for us to be able to do the work that we need to do to defend against modern adversaries. Right? At the same time, it needs to be a proactive operation. Historically, we've waited for those alerts, right? And I think if you look over the last 4 to 5 years, the majority of the large attacks that you've seen were driven initially by a spear phishing attack against some users. And the adversary got some valid credentials. They use those credentials to log into the infrastructure. So as a guy who protects infrastructure, that means the vast majority of attacks that I see start with a valid username and password, with that user accessing a service that they have permission to access. Right? So your traditional tooling like antivirus, AWS, or IDS, WAF, all these types of things, they don't help you with any of these scenarios because the attacker is using a valid access path. Right? So then you get into, you have to actually go into the environment and look for evidence of adversarial behavior. And that's how you find the APT. So you can't just sit back and wait for your tools to tell you that someone is there. The adversaries will stay in the environment for too long if you do that. And then finally, security is needed to make a change to being expertise in business enablement. Right? In a lot of cases, security got a reputation as being the land of no. Right? So anytime the engineering teams, the operations teams wanted to go do something, they go to security, and it was like, ah. And you still see some of that. We were talking about containers just a second ago. Right? And the vast majority of security tools have not adapted to a containerized world. They just haven't. Right? So it means that security organizations lose visibility in containerized infrastructures in a lot of cases. Now that's changing, which is great. Right, but there's still a lot of security organizations that are a little bit of Heismaning when people are trying to do that, and we can't be that. Right, the rate of change that's required for businesses to stay at the front of where they need to be needs to be enabled by security. Right, so this is what we need to go build from an operations perspective, and if you look at all this, none of this is technology dependent. Right, it's not tied to the underlying infrastructure. But in reality, if you want to deliver this operation on an actual infrastructure in the real world, then that infrastructure matters. You can go to the next slide there. So when we look at how or what we need from an infrastructure to deliver these type of operations, the first, as we mentioned, is visibility. We need to be able to see what's going on, right? And that includes network visibility, that includes host visibility, that includes visibility of the underlying substrates, called the undercloud or the overcloud, and all these different types of components. We need to see what's going on. Right? And so all of that telemetry allows us to use the machine learning components and the behavioral analysis components to actually find interesting things in the infrastructure. At the same time, if you do all this work and you get all this visibility and you have a great security operation and you find the adversary, then you need to actually do something about it. So the longer the adversary is resident in your environment, the easier it is for them to move across your infrastructure, get to where the sensitive data is and exfiltrate it, which tends to be their goal. Right? And so the goal is we need to be able to respond as quickly as possible when we see adversarial behavior in the environment. So we need an environment that's capable of allowing us to do that. If I have to put in tickets and wait for a week for a particular change to be made or those types of things, then that slows down your response and it gives the adversary time to do what they're going to do. At the same time, as a managed security provider especially, but I think every security organization deals with this, is we need to be low impact on the ops and engineering teams. Those teams need to be able to use new technologies. They need to be able to deploy quickly. They need to not be running through gates and types of things that slow down what they need to do to enable the business, right? So we need to be able to meet our security objectives without preventing the other teams from continuing to improve on the type of work that they do. And you saw a lot of friction here around things like CI/CD and continuous deployments and some of those types of things. I think a lot of security organizations really started to struggle when operations teams wanted to deploy 20 or 30 times a day. Right? And that broke a lot of models that we historically had, but that can't be the case. We need to be able to do it. And then finally, a modern security operation is predicated on the fact that you will be breached. If an adversary is going to spend enough time, energy, and money, they will get into the infrastructure at some point. Right? And so we spend a lot of our time on detection and response. Right? But that doesn't mean that deterrence is a thing that we don't still do. Right? And so a deterrent infrastructure is an infrastructure that is inhospitable to attackers. It makes it harder for them to do their job, and it drives their costs up. All of that's good, right? It means that hopefully they'll go pick on somebody else. But even if they don't, it slows them down, right? And it takes the longer for the adversary to move through the environment, and it means they have to be more aggressive. Both of those things buy me time as a security operations guy to find them in the infrastructure. So when we look at an infrastructure, we want that infrastructure to be capable of doing these deployment and deterrence kind of operations. And a lot of them, historically, it has been too difficult to do some of that type of work. And we'll talk a lot about microsegmentation and some of those things today that kind of fall into this bucket.
There we go. Thanks, Jared. So let's do a little bit more and talk about NSX and how we address some of these challenges here. But first, I wanted to give you an idea, for those of you who are on the IT side, not the security side, an idea for what happens when a security practitioner is exposed to the data center for the first time. And the first response is going to be, what's the big deal in the data center? Hey, it makes it easier, actually. We've got everything nicely networked. I've got my routers and switches placed here. I've got my stacks here. I'm like, okay, and I'm gonna plop a firewall right at the ingress point to the data center, because I've got that lets me buy that biggest firewall that I always really wanted, right? And I'm gonna drop a few more on top of those racks to do maybe some isolation within the data center, because hey, I'm progressive. I know about this stuff. But oh yeah, there's a little bit of virtualization going on inside of these servers. I think that means yep, there's applications and what are these desktops running inside of the data center here? Wait a minute. There's lots of desktops. What's up with this whole VDI thing, right? It's like my users are outside the data center. My data is in the data center. That's why we call it a data center, not a user center. It's like, what's going on here? And of course, oh, okay, there's my applications. I understand that. And these virtual machines are all over the place. And oh, whoa, what just happened? Wait a minute. I had my security policy set up for that VM to be over there, and it just went over there. Like, no, this is not okay. So here's how. Okay, Mr. My IT brother here. This is how we're going to do it. You're going to put all of these workloads over on this rack, and those workloads on that rack, and I'm going to put the firewall, and this is how we're going to make it. It's kind of make it work. And of course, IT's response to that is like, no way. And of course, and then the business response to that is, you guys are making this way too complicated. I'm going to the public cloud. So that's the big deal in the data center. So how does NSX deal with this? So much as we've virtualized the hardware and storage and basic networking layer with vSphere, what NSX does is implement all of the standard networking appliances, routing, switching, firewall, load balancing, in the hypervisor, and then make these available across the entire surface of your data center, so that you can treat it as a single infrastructure and attach your applications to that. So when we do that, we go from the challenges that we had with visibility, control, inserting our control points, multi-vendor integration, and lifecycle management. We have some solutions to this with NSX. We end up with visibility that stretches all the way from the entire data center view down to the individual endpoints and the processes within there. We have the ability to insert control points at basically every single NIC for every single either physical or virtual appliance that's running in the data center. We have the ability to do service insertion. So instead of having to put a firewall at the top of your rack and hairpin your traffic around, we can actually help you insert your favorite vendor best-of-breed firewall virtually right there at that same insertion point, right at the VNIC. And lastly, we have a whole bunch of automation tools for lifecycle management. I'm going to talk about each one of these things quickly here to give you a little overview of some of that. So starting with visibility, when we want to look at the entire overall data center, the entire network, we have incredible tools such as vRealize Network Insight. How many of you have used VRNI or? Okay, great. So a good number. Good experience. Yeah, you see a lot of things that you like. I'm seeing head nods. VRNI is an incredible tool for understanding what's going on. I mean, even just at the beginning, understanding what's going on in your data center. If you look down on the little table there, that top left number is the percentage of east-west traffic in the data center. And if you're in a data center where your firewall is just sitting at the edge, that's the amount of traffic that's completely uninspected and uncontrolled. So VRNI will help you understand where those flows are going, and even give you some insight into where you might want to plan some microsegmentation to go along with that. NSX also has a very interesting new capability called what we call Application Rule Manager. And what that does is it allows you to choose a few different VMs that comprise an application, do some profiling on that, and it will tell you who's talking to who, over what ports, which protocols, and then suggest a set of microsegmentation rules specifically for that application. So you don't have to sit there and figure out and try and talk to the developer and say, okay, Mr. Developer, what ports do you need open? He's like, I don't know, 80? Because honestly, most developers aren't necessarily aware of everything that's going on in there. So, and then we can actually get all the way down into the endpoint and be able to tell you from a process perspective with the endpoint monitoring capability. If you look here, we're telling you which process is running and on a host and what processes they're talking to on other hosts. So we give you, this is incredible visibility all the way from the process to the socket to the interface across the network and then to the other end on the same thing. So this becomes an incredible tool for being able to do your microsegmentation planning as well as understanding what's going on. Speaking of microsegmentation, I didn't want to spend too much time on this. I suspect most of you are familiar with that. But the idea here is that we can decide how we want the traffic to do based on things like tags. Is this been tagged as a web server? We're going to attach web server policies. Or we can say it's in this virtual VLAN. We're going to apply policies to that VLAN as well. But the whole point is we are attaching policies to an object, not a location. Talk about network and host service insertion. We can help you install things like agentless antivirus on VDI workloads, or install next-gen firewall or IPS services automatically within the workload. And once you've got this set up on a cluster, all of the pieces that are necessary to make that happen, including the security virtual machines from the partners, are deployed automatically whenever a workload is instantiated. And just to give an example here. This is what happens when you want to create a policy associated with a security group. And a security group was what you would use to contain a selection of VMs that might have a specific tag, like let's say PCI, for example. So any VM that came up and was identified as a PCI workload would be part of the security group and inherit a specific policy. And that policy might have a specific policy for guest introspection. So it must have antivirus installed, and it must be inspected in these ways. We'll have a policy for firewalling. These are the firewall rules that we've decided are appropriate for or mandated for a PCI workload. Have a policy for network service insertion. So there might be an NGFW policy, there might be an IPS policy that's in there. And when you instantiate that workload, that automatically gets deployed. And when we talk about partners, I suspect we see probably the major vendors that you work with in this slide here. And we are adding them all the time as well. For the last part here, I wanted to talk a little bit about lifecycle automation and lifecycle management and automation. So there's kind of two halves to this, and we've been struggling with the naming and so on. So please pardon me in advance if it doesn't apply exactly to your situation, but essentially we're talking about the things, orchestration and automation that happen before an incident and orchestration and automation that happen after an incident. So before an incident, essentially we're talking about application delivery, being able to define a set of VMs that comprise an application and say, here's what we need these web servers, this 3-tier app, I'm going to find the policies, and it's going to be deployed and replicated and so on. And then on the other side, we've got automation that, this is where we're going to be, we're bringing in Robert here to talk about this today, is automation on the incident response side. So that's where you've got all these different applications that you really, really, really need to work together very quickly and very efficiently in order to respond in a timely manner to any kind of attempted breach. So starting on with the first part of the lifecycle management, I think how many of you are using vRealize Automation Suite? Okay, so once again, a fair number of you. And for those of you that haven't looked into it yet, I highly recommend you look into it from the perspective of creating your own service type infrastructure within your IT organization. But when we're talking about vRealize Automation, what we do is we take all those components that I mentioned with NSX, we combine that with things like the blueprints, with the service catalog, with policies that are associated with that, and a cloud management platform. And what happens is we now have automated service delivery. And this can be instantiated and replicated multiple times and stamped out as needed. And I think as you've seen in some of the keynotes over the last few days, there's a huge amount of work being done on this to expand it, not just on your on-prem private cloud, but also into public cloud and hybrid deployments as well. So at this point, I'd like to pass it on to Robert. Whoops. And I'm going to have to turn myself off so you can talk. Thanks, Rob.
All right. Thanks. Okay, here we go. So a little bit about Phantom and what we're doing within the SOC. So I think it's helpful for everyone to first lay out what the SOC typically looks like from a workflow perspective. And we use the military term, the OODA loop, observe, orient, decide, and act, as an analogy to really describe the SOC workflow. So we'll take it from left to right. On the observe side, we have your point products, things such as firewalls, IDS, IPSs, endpoint detection and response, malware analysis. Many of these may be physical appliances or they may be virtualized, but they're responsible for enforcing security in your environment as well as detecting breaches. Now, when something is detected, it's fed into an analytics platform. This is your orientation part of the diagram. We look at things like SIEMs, threat intelligence platforms, data lakes. These are going to collect all of the security information from the point products, apply correlation, analysis, and spit out effectively an alert or many alerts to a SOC analyst. Now that process is very well automated today. There's been decades of innovation going into those point products and exchanging information between those products. So the workflow is highly automated. But once you get that alert or many alerts to the analyst, they then need to decide what to do with it, and it's not a quick decision. They have to analyze all of the information that came in from the alert, use other tools to enrich that information, decide what to do, and then ultimately act on it with the point products. That process is very much manual today, and it's what is hurting a lot of the SOC operational workflow. It's slowing them down. It's decreasing the speed of response, and you're spending very valuable human resources doing repetitive things. Instead of doing highly intelligent tasks and investigating real security topics, they're doing things like opening many tabs to the variety of tools inside of their environment and copying, pasting data from one tool to another, and just fetching information that could be automated otherwise and save them a significant amount of time. So that's what Phantom is aimed at automating today. Again, the observe and orient side, a lot of innovation, a lot of automation has gone into that part of the SOC. But on the decide and act, there hasn't been a lot of research done on that part of the process. And that is what Phantom has invested in. And we've spent the last 3 years building the industry's best automation platform that allows analysts to draft these workflows. Basically, when they receive the alert from the analytics platform, allow them to draft exactly what steps they want to take to investigate that alert and take action on it. And what that enables them to do is run it automatically at machine speed at a very high scale. Because I'm talking about one alert, but in reality, it's hundreds, thousands, if not tens of thousands of alerts per day, depending on how big the organization is. And from a SOC team perspective, your team size may be on the order of 1 or 2 guys in some cases, maybe 5, maybe 10, 20, but your capacity from an analyst perspective is on the order of anywhere between 5 to 15 alerts per day. So do the math. If you get 1,000 alerts daily, that's a pretty big staff that you need, and therefore a big gap if you're triaging all of those alerts manually. That's where automation comes in. It can help close that gap. Now about Phantom and the workflow. We start with a data source. So Phantom is going to ingest high-fidelity security data from a data source. I mentioned before this could be a SIEM, threat intelligence platform, data lake, anything that's doing any type of analytics on the information it's received from the observation platforms. So we ingest high-fidelity security data, and the first thing that happens is an automated playbook or many playbooks execute against that security data that's been ingested. The playbooks are the digital codification of the human response plan. So all those steps that I was referring to previously that an analyst would execute upon receiving an alert, that can be rolled up into a playbook. Playbooks ultimately execute actions. There's a list of actions there, things like block IP, file reputation, IP reputation, detonate file. These are individual tasks where you would be reaching out to a tool and executing that particular action. Now, these actions are intentionally generic, and that's so the analysts can focus on the workflow, not necessarily the vendor-specific API. One of the other challenges that SOCs have are that there's a wide variety of tools that these operators need to interact with, sometimes on the order of 30, 40, 50 different tools, all from different vendors, and they all have different APIs. So it can be very time-consuming just learning how to interact with each of these APIs. Phantom will simplify that by exposing simple actions in generic ways to allow the analyst to focus on the workflow. Now, there's an abstraction that needs to occur to make that happen. That abstraction happens at the app layer. The apps are written in Python. They're modules that plug into the platform. We're going to show the NSX module today. It's one that we'll be demonstrating. And what it does is it takes that generic action and then it packages up into a format that's fit for consumption by the API specific to that vendor. So we're going to show a few actions with NSX today, things like block port, block IP, apply a security tag. The API used in NSX might be something like NSX block port. There's some vendor specificity associated with that API call. But at the playbook level, we'll just be calling add security tag or block IP. We'll specify the NSX platform, and the app is what's responsible for taking that information and then feeding it into the NSX platform, which ultimately executes the rule that was requested. Now, an asset is the instantiation of the interface to that technology. The app defines how you interface with the technology, but you need to have an NSX controller that you're interacting with, or whichever tool you may be using. There's an instantiation of that tool in your environment. It has things like an IP address, a management IP address, management username, password, maybe an API token, whatever it may be. That configuration is unique to an asset. So it describes how you will actually be interacting with that point product. And lastly, there's the notion of ownership over an asset. So if you wanted to insert human approvals associated with particular tools or actions that you would be taking, you could do that through the use of ownership. So a good example would be something like deploying a block IP rule on a firewall or within NSX. You may want to ask the owner of that asset or prompt an analyst in the SOC to see, are you sure? Do you want the automation engine to proceed with this block IP rule? And then they have the option to select yes or no. So it protects you against a scenario where you may be afraid that the automation engine runs wild, but you can always insert humans in the automation loop through the concept of ownership. Now, this is a sample playbook that is being used by Rackspace. Jarrett will talk about it a little bit here, but the basic concept is email phishing, and how do I handle email phishing? This is something that I would say that pretty much every organization has to deal with. Email phishing is a common problem. It's probably the #1 use case that I see customers using Phantom for. There are several others, but the idea is that you can register Phantom to receive emails from your phishing inbox and then execute a variety of these steps that will do things like rip the email apart, do reputation lookups against any content inside of the email, and then ultimately drive action. Now again, going back to the scale side of this, if you had just one email a day that you were receiving that you needed to triage, it may not be that big of a deal. But the reality is you're receiving hundreds, maybe thousands of these per day, and they take up analysts' time. So again, imagine you have a team of 10 analysts that could triage 10 emails per day. So you have a capacity of 100 emails, but in reality, you're receiving 1,000 of these, maybe several thousands. There's just no way to keep up. You have to apply automation to close that gap. Jared, is there anything you want to add to this?
Excellent. So what we want to do is actually walk through kind of an example of what this actually looks like, right? So I know we've done a little review of kind of some of the things that are in NSX and the capabilities it has today, and we've done a little review of what Phantom does. And we wanted to do all of those so that we get ready to talk about how we start to push these things together to get value from the automation platforms. So this is an actual example from Rackspace today. And so in a lot of cases when we get a phishing email, this is where the analyst would start in an augmented workflow, right? So it's basically a JIRA ticket that has the contents of the email in it. There's no magic in here, right? And if we look at this path here that we were talking about, you'll see all the various different things that the analyst has to go through and actually do to be able to deliver it. Now, this is an actual example from our internal security operation that protects Rackspace corporate, so our corporate strategy. And so Rackspace is a big company, $2 billion, and it's been around for 15 years. And so like many big companies, our internal infrastructure is super complicated for reasons that no one understands, right? And so our identity infrastructure is no different than I think most of us has dealt with. So the analyst has a lot of work to actually do, right? Depending on where they get this alert from, they got to figure out what user it's talking about and whether it came from internal or external and who it came from and where it's targeted and what systems they have to talk to. And then inside of Rackspace, it turns out there's 3 different identity platforms that they may interface with to perform that operation. Right, and so what you can see here, I'm not going to go through all these steps because it gets complicated, but what you can see here is that the Phantom platform will actually go and do most of that work for you. So it goes and it talks to the right things and it collects the data that you want and it does the work that the analyst would normally have to do, right? And if you see the little step at the end here that has the people in it, right, this is the actual approval that we were talking about just a second ago. So once it goes and it does all this work, it pops up something like this, right? And this is what the analyst sees. This is the first thing the analyst sees now. Right? Now, we redacted a bunch of information, so it's, there's a little bit of stuff that's not shown here in the screen because this is actually kind of internally in production at Rack today. But it allows the analyst to see all the information that they need to make a decision about whether this user needs to be immediately disabled or not. Right? And if they do, if they hit yes, if they hit complete here, then the automation will go ahead and do that work. Right? So while that entire process from beginning to end may only take 20 minutes for an analyst to do, as we were talking about, they may get hundreds of these. Right? And hundreds of these a day chew up analyst time, and maybe that's a half a head. But again, remember it's a 24/7 operation, so a half a head is actually 3 or 4 people that I have to staff to cover all the shifts, to cover training, to cover people who get married, to cover weekends, all those things. Right? So as someone who has to write a check to pay all of those analysts, it is much, much cheaper to not have to go and hire people to do this. And most of our analysts are much happier not doing this work. Right? Because they want to go and they want to be fighting the bad guy. This is block and tackle stuff, right? This is not using the expertise that those folks have. If you have 15 years of offensive and defensive cyber warfare experience and you're spending most of your time screwing around in LDAP queries, you're not going to be a happy camper, right? And so these are the types of things that we can start to tackle with automation. And what's interesting is we've so far talked a lot about kind of IT automation processes and security automation processes, and they have historically been different things. right? But the benefit is that as the underlying infrastructure platforms like SDDC have allowed themselves to kind of become API enabled and various other things, we can now start to push these two things together. So the next example that, and demo that we wanted to walk you through is around WannaCry. So how many people have heard of the WannaCry attacks? I think pretty much everybody heard all that nonsense, right? So good. So we wanted to use this one because it was an example that we dealt with at Rackspace. So this is something that was live for our customers. So we had multiple customers who were impacted by the WannaCry ransomware, right? They weren't impacted in the environments that we protected, right? They were impacted on environments that were outside of Rackspace, so maybe on-premise or some of those types of things. And so when a customer looks at it, we knew that their environments at Rackspace were vulnerable to this particular vulnerability, right? They hadn't been patched. And in a lot of cases, as most security people in the room, there are quite a few of you here know, patching at scale is very difficult, right? And so those businesses were not being impacted by WannaCry today. At the time that we were talking to them, it wasn't active in their environment. So to just go and patch all their stuff would cause an enormous amount of business impact, cause downtime, various other things that they wanted to avoid. But they didn't just want to pray that they didn't get popped, right? And so what we did is we sat down with them and we came up with a plan to say, okay, here's the deal. We're going to monitor your infrastructure. And the minute that we see anything that looks like WannaCry, whether it's network traffic or host traffic or those types of things, we're going to immediately take actions that we have all pre-approved, right? So no one's going to be asking anybody for permission. We're just going to do it very quickly to limit the scope of that damage, right? And putting that in place allowed those customers to not necessarily go and patch right away and figure out how to do that in a way that was going to work with the business, but also put something in place that if the worst did happen, then they would be able to respond effectively and the business wouldn't be overly damaged. And so what we want to show is what something like that would look like if those customers happened to be on SDDC, which they weren't, so we had to do this manually, right? But we want to show you what we can do with these platforms as we start to link in the IT automation components and the security automation components.
Excellent. Thanks, Jared. Okay, so from a playbook perspective, how we bring these two worlds together, specifically in this WannaCry scenario. What we're showing here is the Phantom platform ingesting high-fidelity security data from Vectra, which would be supplying us an alert signifying a ransomware event, specifically WannaCry in this case. Now, when Phantom ingests that event, the first thing it's going to do is reach out to NSX to block port 445 at the vSwitch level on the affected endpoint immediately. So this prevents the ability for that ransomware to spread laterally. Next, we will end up prompting the analyst or a group of analysts to see if they want to move forward with quarantine or some other type of network containment type action against that endpoint. They'll have the option to accept or reject it or even delegate it to a different analyst or manager to make that decision. But again, it's showing an example of how you can insert a human in the automation loop to make a call as to whether you want to move forward with more severe actions or not. In parallel to all of that, you have the option to also interface with a ticketing system to create a ticket documenting that the block port rule took place, or maybe the block IP rule took place. And then from a forensics perspective, leverage vSphere to snapshot the VMs that were affected, so you could go back after the fact and analyze the virtual machine to understand how this actually occurred in the first place. So we're going to step now into the Phantom platform and show you how this actually works. So give me one moment while I hit the switch, and it worked. All right. Warning, live demo, right? We all know that things could blow up on a live demo, so we'll see. But I think this will run pretty well. So first, let's look at the event. We've ingested the event from Vectra. Right here, we have two endpoints that have been affected. So Vectra has signaled to us that there's been a ransomware sighting, and we have two endpoints that have been affected. So what we're going to want to do is go ahead and launch our WannaCry playbook. So this is called our WannaCry Fast Response. Zoom in on this so you can see. And we'll go ahead and launch this. Now you can see right out of the gate, it's gone ahead and in less time than I can zoom on it, went ahead and blocked the port on NSX. So back to what Jarrett was saying, as soon as we've seen that this event took place, let's start taking action immediately. In parallel, it created the ticket, and you can see here that it's issued a prompt as well. Let's take a look at what the prompt looks like. So we'll pull up our prompt, and you can see here that I have a message saying the following hosts have been identified as WannaCry victims. Do you want to proceed with a quarantine? In this case, I'm just going to say no for the sake of demo. We'll jump out. The prompt's completed. We're still listing all of the VMs that are within the environment. And what's happening at the playbook level is when we retrieve the VMs, the list of VMs, we're going to compare it to the IP addresses that have been affected and see if there are matches. If there are matches, we're going to proceed with snapshotting the VM. So you can see that just took place right now. So we listed our virtual machines, matched them against the affected endpoints, and we're snapshotting them so that we could look at them offline and understand what actually occurred. Now, I kicked off that playbook manually. I ingested the event from Vectra, went to my on-demand playbook execution window, and launched the playbook. In a real-world environment, once you're comfortable with the playbook, what you're really going to want to do is set this to an active mode. This active toggle will basically allow that playbook to run automatically as soon as the event is ingested from the data source. So this is, again, going back to speed of response. If I have an alert that I've ingested from Vectra and it comes to an analyst, and I don't have automation in place, it still requires the analyst to open up the alert, look at it, figure out what they want to do. And even if they have a playbook to run and it saves them time, they still have to manually kick it off. The best way to proceed with something like this, especially in a crisis scenario like WannaCry, is to enable the playbook to run in an automated way. And that's what this active toggle does. So at the next time an event is ingested, this workflow will execute automatically. So what the analyst sees is they log in, they see the event, they see, oh wow, great, the block port has already been deployed. I'm comfortable that this is not going to move east-west. Then they're left with the prompt. Do I want to take additional action on this? Do I want to move forward with a quarantine? Or maybe other IP blocking rules if need be. They have that option. And then, as I showed you before, you can accept or reject.
This is a really great example of security being able to get to have a conversation on a business level with your stakeholders. Right? By having capability like this, you can go to your stakeholders and say, hey, look, we have some options on how we deal with something like WannaCry. Right? And so we don't have to take the business down. It's not a black and white situation, but it is a risk-based conversation. So imagine instead of this being SDDC where I can deploy a block rule in milliseconds, imagine this is a traditional firewall environment that's going to require a ticket or something like that. It may take 2 hours. Right? As security people, are we then comfortable telling the business, yeah, that's okay? Well, no, probably not, because it's going to move quickly through the infrastructure because it's automated. But in this case, we might be able to. Right? So when you start automating these things, it gives us options that we can have conversations with the business about that allows us to keep those things up and achieve business goals while still meeting our obligation from a security perspective to reduce risk to the business.
Excellent. So we're going to jump back. Let's see if this works. Number 3. Excellent. Okay, so we talked about WannaCry because that's near and dear to us. It just happened, right? But another scenario that is also frequent, now this is a little bit more generic, we're not calling out a specific threat, but a CNC, a command and control. So in this case, what would be happening is you'd have a detection device identify that there's a CNC session ongoing inside of your environment, and that alert would make its way to the Phantom platform. From there, a series of investigative tasks by what would be an analyst, but in this case it would be the automation platform, would be executed. Things like looking up the IP reputation associated with the destination IP. There are a lot of services out there where if you submit them an IP address, they'll submit back to you effectively a reputation score. How malicious or dangerous is this IP address versus others? The same thing occurs with file reputation. So you can do file reputation lookups if there was malware associated with the CNC. You can submit a file hash and we return back to you a number of positive detections based on a wide variety of different malware scanners. The same thing goes with threat hunting. So you can obtain threat intelligence reports associated with particular IP addresses as well as files. Again, all of this is work that an analyst would be doing as soon as that alert lands on their desk. Now what they want to do is empower an automation platform to go out, fetch all that information for them so that they don't have to open 20 different browsers across 2 windows to view it, and then ultimately make a decision. When the decision comes in this particular case, we're going to decide to do two things. One, if we have a malicious file, we're going to use something like Carbon Black or some other endpoint detection and response type of tool to reach out and install a rule that will block this malware on every endpoint being managed by that particular tool. That's what that block hash rule is. And then second would be to block the IP address associated with the CNC session using NSX. So what's great about this is you're reaching out very quickly to a centralized controller, in this case NSX on the IP side and something like Carbon Black on the endpoint side, giving it a rule or an instruction, and it's going to reach out and affect all of the endpoints within that domain to ensure that particular rule is deployed.
And one of the side benefits to pushing these automation components together is teams that historically may have had some friction. Security and engineering and operations don't always get along very well. These can start to help a lot of those scenarios. Right? Because imagine if we have to do all these things by putting tickets in and calling various people and getting people to go and actually do individual work, it becomes very difficult. And by using the automation to also perform the documentation function, you make sure that everybody who needs to be involved gets involved. So it becomes a scenario where all of us are trying to respond to the same incident at the same time, as opposed to everybody trying to kind of do their own thing and kind of going at loggerheads a little bit. So like by pulling these automation platforms together, you can really start to get teams that may have historically had some friction to start to get on the same page and kind of rowing in the same direction, which can be really powerful.
Excellent. So we're going to jump to the demo. So here's the visual representation of the playbook. Something I mentioned before, all of these workflows, they're Python underneath the hood. That's what the automation engine interprets. But you can craft these with the visual editor in a very business process modeling style interface. It looks a lot like Visio. It's a drag and drop. You specify the actions. You can bake in business logic, data filtering, user approvals. Those type of things are all accessible from the visual editor. So it's great. It enables a wide variety of stakeholders in the environment to interpret as well as develop these workflows. So let's jump to the event itself. We'll pull up the C2 alert. And, excuse me, the same drill. You can see here's the original event that was ingested. Here are all of the destination IPs that are associated with this CNC. I can also look at things like domain, destination domain addresses, file hashes, if there are any. I can look at source addresses as well. But ultimately what I want to do is launch a playbook. So let's pull this up. Let's look at our C2 playbook, and let's run this. So you can see in the lower left-hand corner, and I'll zoom in for you, here the automation platform has automatically gone out and it's obtaining threat intelligence information associated with the file, the offending IP address. It's doing reputation lookups on the IP as well as the file. And you can see already down here, after the IP reputation lookup executed, the block hash rule also successfully executed. So within a matter of seconds, and again, this was me manually kicking off this playbook, but in a matter of seconds from detection, we now have block hash rules distributed across all of my endpoints. The same thing is occurring on the IP side as well. I'm doing my IP reputation lookup in the playbook, interpreting the results, and then automatically reaching out to NSX to ensure that the offending IP addresses are blocked at the vSwitch level or the hypervisor level across all the endpoints being managed within that domain. So right now, we're also looking at snapshotting the VM in parallel so that from a forensics perspective, you can look at this information offline. Now, the same thing that we did with the WannaCry example, I launched this playbook manually. Once you're comfortable with the playbook, what you're going to want to do is, again, make sure that you're activating this. By toggling this active button, you're enabling the playbook to run automatically such that each time that that event is ingested into the platform, this workflow is executed automatically. The analyst, when he logs in to view the event, what he sees is that a block IP rule was deployed with NSX, block file hash with Carbon Black was deployed. They now have a snapshot of the affected VMs, and it's a much better starting place for the analyst than it is to have obtained the alert and then have them have to figure out exactly what they need to do by researching the indicators, enriching the data, and then acting on it. So our starting point is far more mature at this point with the tool. And not only that, but the speed of response. Again, think about this. You could have, at the time of people switching shifts, right? Some people may not be monitoring these tools full time. With an automation platform, looking at the events coming in, kicking off workflows automatically as they're coming in, you have the comfort to know that the basics of what you want from a security procedure perspective are being executed without a human looking over it. So that's it from a demo perspective. Rod, I'll hand it back to you.
Great. Thank you very much, Rob. And I'm super impressed that that's 2 consecutive demos that actually worked flawlessly. Very impressed. And one of the things I want to mention here about Phantom is what this really does is it allows us to integrate NSX into that security ecosystem right now. You don't have to rely just on the certified integrations that we've done where the partners have actually done a bunch of additional work in order to integrate deeply in. If you want to integrate at a superficial level, this provides the way to be able to integrate basically any security application into your NSX infrastructure. So moving on to what's next here.
Right, so we just wanted to close with a little bit of a wrap up of kind of how these platforms that we're talking about enable that modern security operation. Right, so when we look at things in NSX that allow us to do a lot of what you just saw, the first of it is kind of software-defined networking, for sure, really software-defined everything. Right? The reason we're able to make those changes from an automation perspective is because SDDC gives us the ability to do that in an API-driven automated fashion, and that's code that my team can write, or that we can use code from various other folks like Phantom who have done a lot of this work for us, which is great. Right? The fact that that infrastructure is API enabled is the only way you can do this. On dedicated gear and various other things, these processes would take hours and involve multiple people from different departments, which becomes very difficult and costly to actually do. And all of these platforms support the orchestration integrations as we were just talking about, right? We used a bunch of tools today. Those are just the ones we happen to pick. There are hundreds of tools that you can use to do this. And so it allows you as an IT and security organization to decide what are the right things for your business, both from a cost perspective and a risk perspective, and deploy those, but still get the benefit of a modern automated security operation. And then finally, we talked a lot about deterrence, and we went through a lot of the components in NSX, and all of the automation that is IT automation that allows us to actually deploy all that stuff, automatically deploying AV and IDS and all those types of things, that allows us to really actually deploy a lot of these deterrent components to the infrastructure. There's lots of stuff that security people wish we could do in every IT infrastructure, but it's just too hard. It's too much overhead for the IT and engineering organizations to constantly care and feed all that stuff, and that leads to some of those frictions between those teams. So now security can go and they can define security and compliance and regulatory requirements that can then be completely automated so that the IT operations teams don't have to deal with them on a day in, day out basis. Right? And all of that gets enabled by having that infrastructure layer that is capable of responding kind of programmatically and then layering those orchestration components on top of it.
Thanks, Jared. And so basically saying the same thing in a slightly different way from a more NSX-centric perspective here, we talked about the requirements here for when we're talking about automating security in SDDC. And the first one was visibility, and I think we've talked quite a bit about that. The microsegmentation that Jarrett was alluding to, the service insertion, and finally the lifecycle management and automation, both with the pre-incident types of deployment tools as well as the post-incident tools such as Phantom. When we talk about how to get started here, there's a number of things for you to use, especially looking on the right-hand side if you want to download and try some of these things. So we have the application that was built to integrate NSX with Phantom. I want to, Ganapathy, if you want to stand up, and I'll take. Ganapathy built that over the last few weeks, so thank you very much for that. And it's actually it's open. We've got it up on GitHub, so you'll be able to make your own changes to that, or build your own integrations as well, if that's something that you're interested in.
And for those of you who want to try out Phantom, for example, they have free demos and stuff like that that you can try out for your infrastructure. And so, like, this is stuff you can go out and do today. In fact, we've actually changed our training process for all of our onboarding analysts now, that we teach them Python. And most of them already know it, but the ones who didn't, we teach them now. And the reason we did that was to be able to use platforms like this, right? So it can really make your teams a lot more effective and scale.
won't let me go to the question slide, but you can ask questions anyway.
Yep. So we got about 5 minutes for questions, and then the three of us will hang out outside the doors here for those who want to ask additional ones. There are 2 microphones. Get close, otherwise we won't hear you. Good job.
Are you able to take action on, such as the WannaCry, to understand what user is actually has it been infected, to then send a log out to that user and disable that user in AD?
Yeah, you can get basically as complicated as we want with these things. So we only showed a couple of views, but you have all the information that comes from back from SDDC you have. If you have an endpoint control platform, then like CrowdStrike or whatever, you can link to individual processes if you want. The inspection from NSX can give you process connections and user connections and those things. Then you can go talk to your identity platforms and pull those things out and lock people's accounts and those types of things. So you can get as sophisticated as you want. And most of those integrations are already built in. You just have to orchestrate them all together. I don't know if you wanted to add something to that, but
I think you covered it. Doing things like reaching into Active Directory with OutApp and disabling users, and not only that, but notifying the analyst, capturing all of the information associated with users, connections, files, anything associated with that endpoint. You can very easily snapshot all of that, take it, package it up, notify the analyst via a prompt, or there's even baked in email. You can send an email to a collection of people that have that information contained already. Some cases, they'll also file that in a ticket, so they'll use something like Jira and file all of that into a ticketing system. But it's really a Swiss Army knife in that regard. You can capture any information you want and send it really in any way you want.
And this gets really powerful when you're using like Azure AD or a CASB or something like that, because then you'll have users that are remote, they're on their phones, they're on whatever, and you can very quickly kind of lop off that entire control structure so that they just can't touch anything. So we've started experimenting with doing that with things like software-defined perimeters. And so, the kind of transparent on-demand VPN type stuff. And being able to kind of interrupt immediate control. So even if they already have access and it's a currently standing access, you can take it away, right, and actually break that right there. And that stuff gets really interesting and useful. Now you have to decide how grumpy you want your users to be too. So there's always that trade-off that you have to do. Yeah. Mm-hmm. Yeah. And so, depending on what so you certainly can do some of that stuff depending on what access to APIs you have, right? And so sometimes you may not be able to depending on what it gives you, but most of the time you can be pretty aggressive about kicking them out of the organization if you detect something. Yep. Yeah, and so if you have a platform control, an endpoint control platform like Tanium, right, then where you can execute whatever you want on that remote host, then something like that becomes very easy, right? Get real close to it there.
The question I have is, a smaller business, do y'all have any tie-ins for you build a platform like NSX at your environment, like an outside, like a security as a service platform, or defense as, you make up terms, defense as a service, where you tie in, or say SecureWorks or somebody that will tie into your NSX environment?
Yeah, so look, I'm a managed security service provider, and so this is the type of stuff that we want to be able to do. Today we do it on Rackspace managed environments because we can kind of control how it's deployed, but we'll be doing it for customers on-prem environments as well. So this type of thing makes our job a lot easier to do exactly what you're saying, right? I can tie into that infrastructure without disturbing a ton of it, and so that means that customers, organizations, IT and engineering organizations are less disrupted by third-party services, because I'm never going to know your infrastructure as well as you do, right? And so being able to kind of come in and do that remotely is a really powerful component of the NSX integrations that we can do.
Yeah, we have in Phantom, so we have a selection of them right now, but we'll be building it out as we go. I think we started off with the block board, block IP, set and clear tags, and so on. But yes, most definitely.
Yeah, that's the important bit, is that so our analysts write these things. You don't even need an engineering team to go write them if you don't want to. It's useful to have, right? But you can just go write your own, and it's pretty straightforward to do. So.